Hello students, in this video I start compound angles. So now let me discuss about what are compound angles. Okay, the algebraic sum of two or more angles is called as a compound angle. So far you have seen the angle like 30 degree, 45 degree like that. And if it is unknown angle, you will call it as angle A, angle B, angle C like that. Suppose you are referring the sum of two or more angles A plus B, or sometimes difference B minus C, A plus B minus C. Okay, these are all called as compound angles, and these angle A, angle B, they are called as constituent angles. Okay, so in this video I am going to prove a theorem cos of A minus B. Here our compound angle is A minus B. Cos of A minus B is cos A into cos B plus sin A into sin B. So for this I consider a circle. Okay, if it is a circle of any radius r, then the point on the circumference of the circle with reference to this angle, suppose this angle is theta, then this point on the circumference of a circle is given by r cos theta comma r sin theta. This means the x coordinate of this point is r cos theta and the y coordinate of this is r sin theta. Keeping this in mind, let me prove this theorem. So in order to prove this theorem, I will consider a circle of unit radius. Okay, I will write consider a circle of radius 1 unit. So here this is the radius. So I will consider a coordinate system. This origin O is the center for this circle, O 0, 0, and let this point is on the circumference of a circle and it is lying on the x-axis. Let me call this point as P0. The coordinates of this point are, since the radius of this circle is 1 unit, x coordinate of this P0 is 1 and y coordinate, it is on the x-axis means its y coordinate is 0. Now I consider an angle A as the circular angle A. Then the point on this circular angle is the point on the circumference of a circle is represented as, this is P0 means let me call this as P1, the coordinates of this point. I told any point on the circumference of a circle is given by r cos theta comma r sin theta. Since r is 1 here, the angle made here is A. So the coordinates of A are cos A comma sin A. That's what you can refer here, cos A comma sin A. Then I will consider one more angle. Let this is angle B. Okay, I will call this point on the circumference of circle as P2. Since this P2, OP2 makes an angle B here, the coordinates of this point are cos B comma sin B. Okay, now this is angle A and this is angle B. Let angle A minus B is somewhere here. I will call this point as P3, as you can notice here. Okay, P3. Okay, P3 has the coordinates cos of A minus B comma cos of P3 has the coordinates cos of A minus B comma sin of A minus B. Now there is cos of A minus B comma sin of A minus B. This is P0 1, 0. If you join this one P0 P3, okay, this is as same as the length P1 P2 because P1 has cos A comma sin A and P2 has cos B comma sin B. So from this diagram, consider a circle of radius 1 unit. P0 has the coordinates 1, 0. Let angle P0 O P1 is equal to angle A, P0 O P2 is angle B, and P0 O P3 it is A minus B. The coordinates are P1 has the coordinates cos A comma sin A. Okay, then P2 has the coordinates cos B cos B comma sin B, and then P3 has the coordinates cos of A minus B, because A minus B is a circular angle for P3. Then comma y coordinate is sine of A minus B. Okay, and you know P naught is 1 comma 0. From the figure what we have noticed? We have noticed P naught P3 is as same as P1 P2. P naught P3 is equal to P1 P2. Now by the distance formula, let me find out what are P naught P3 and P1 P2. By the distance formula, P naught P3 is equal to, you know, the distance between 2 points whose coordinates are x1 y1 and x2 y2 is given by x2 minus x1 the whole square plus y2 minus y1 the whole square under root. Here I have P3 has the coordinates cos of A minus B comma sin of A minus B. P naught has 1 comma 0 means 1 x2 minus x1 cos of A minus B the whole square, x2 minus x1 square, plus y2 minus y1 square will be 0 minus sine of A minus B the whole square. Okay. Now squaring on both sides, in order to avoid that root, I can write squaring on both sides. P naught P3 the whole square is equal to, this roots gets cancelled. I end up with 1 minus cos of A minus B the whole square, plus 0 minus means I have only minus sine of A minus B whole square. Minus square is plus, so I get only sine square of A minus B. Now I will expand this in the form A minus B the whole square. 1 plus cos square of A minus B minus 2 times of 1 into cos of A minus B, plus I have sine square of A minus B. Now what we will notice, cos square of A minus B plus sine square of A minus B. It is as good as cos square theta plus sine square theta. That is 1. Together I write it as 1. I am left with this term minus 2 cos of A minus B. Now 1 plus 1 is 2. 2 minus 2 into cos of A minus B. 2 let me take common. I am left with 1 minus cos of A minus B. I will call this as equation 1. Okay. Similarly, I will find P naught P3, I got it. Now similarly I find P1 P2. Now P1 P2. Again I make use of the distance formula. What you have in the distance formula? P1 has cos A comma sin A, P2 has cos B comma sin B. So P1 P2 under root of x2 minus x1 whole square means cos B minus cos A the whole square, plus y2 minus y1 whole square, distance formula. So it is sin minus sin A the whole square. In order to avoid that root, let me square on both sides. Squaring on both sides. P1 P2 distance square is equal to, this root will be gone. I get cos B minus cos A the whole square plus sin B minus sin A the whole square. Okay, you will expand using the formula A minus B the whole square. Cos square B plus cos square minus 2 cos A into cos B plus, when we expand this, what happens? Sin square A plus sin square B minus 2 times of A into sin B. Now again I make use of the formula cos square theta plus sin square theta is 1. Cos square B plus sin square B, it is 1. Cos square A plus sin square A, it is 1 minus 2 cos A cos B plus minus 2 sin A into sin B is there. Now I write 1 plus 1 is 2. 2 let me take common. I am left with 1 minus cos A cos B and again here I have minus sign, means minus sine A sine B. I will call this as equation 2. Now we are end of this proof. What we know? We already know that P0 P3 is always equal to P1 P2. If I make the square, P0 P3 square is equal to P1 P2 square from 1 and 2. I will substitute their values from equations 1 and 2. From 1 we have this as cos of A minus B, and this as 2, sorry, 1, what is P0 P3? P0 P3 I got it as 2 P0 P3 is equal to cos square of A minus B, like that, 2 into 1 minus cos of A minus B. 2 into 1 minus cos of A minus B is equal to 2 into 1 minus cos A cos B minus sin A sin B. Okay, 2 cancels. There is 1 here. 1 minus cos of A minus B, and there also 1 minus cos of A minus B, means 1 minus get cancelled. Cos of A minus B is cos A into cos B, minus into minus, it becomes plus sin A into sin B. So this is the proof of this important theorem. This is very important theorem. Go through it. In examination it is compulsorily asked for 6 marks in part E section.